Okay, so in this problem we have a function f of x squared plus 4x, and we'd like to find the derivative using the limit definition. So we recall first that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Now our function is x squared plus 4x, so we're going to substitute x plus h in for x squared, or x in the function x squared plus 4x. So we have x plus h and then minus f of x. F of x would be x squared plus 4x. That's all divided by h. And so now we begin to simplify. Actually, before I do that, I have to go back and put something in that I forgot to include. Don't forget, this is always a limit as h goes to 0. So x squared plus 2xh plus h squared plus 4x plus 4h minus x squared minus 4x. That's all over h. Now we go through here and recognize, well, I have an x squared and a minus x squared. I have a 4x and a minus 4x. And so now what I have left, I have a 2xh and h squared and a 4h. Every single one of those has h as a common factor. So I'm next going to factor out that common factor of an h. So I have 2x plus h plus 4 all over h. And finally, now that 0 factor can go away as the h's cancel out. And now I have an expression that doesn't have that 0 over 0 issue, so I can allow h to take on the value of 0, and I get 2x plus 0 plus 4, which gives me my derivative as 2x plus 4. Okay, and so that's the process of finding the derivative using the limit definition. You're going to need to go through whatever simplifying process you need to do to eventually get rid of that 0 factor property. Could be a problem involving radicals, could be a problem involving complex fractions, or it could even be a combination of the two. But that's the process that we go through so that we can eventually get the limit into a form that we can compute.